A pleasant day, everyone. I am Jezebel Edan, and now I will going to discuss to you the Atbash cipher. So, what is Atbash cipher? So, the Atbash cipher was originally a monoalphabetic substitution cipher used for the Hebrew alphabet. It is one of the earliest known substitution ciphers to have been used and is very simple. However, its simplicity is also its biggest pitfall, as it does not use a key, hence every piece of a plain text enciphered using the Atbash cipher uses the same cipher text alphabet and so can be easily broken since the encryption algorithm is known to all. The Atbash cipher simply reverses the plain text alphabet to create the ciphertext alphabet. That is, the first letter of the alphabet is encrypted to the last letter of the alphabet, the second letter to the penultimate letter, and so forth. In the original Hebrew, this means that Aleph is encrypted to the Tav and Bet to Shin. This is where we get the name of the cipher Atbash. For the Hebrew alphabet, we get the following conversation table.
The ciphertext alphabet for the Atbas cipher on Hebrew alphabet. For the Roman alphabet of 26 letters, we have the ciphertext alphabet as given in the table below. Encryption. As with any monoalphabetic substitution cipher, encryption using the Atbash cipher is very simple once the ciphertext alphabet has been generated. We simply replace each occurrence of each plaintext letter with the respective ciphertext letter given by the table. So, if we take the plaintext Atbash, we can see that A enciphers to Z and T enciphers to G and so on. Continuing in this way, we see that the final ciphertext is ZGYZHS. So, encryption example. Plaintext is Atbash. Plaintext alphabet is A to Z. Reverse to ciphertext alphabet is Z to A. So if we take the plaintext Atbash, we can see that A enciphers to Z and T enciphers to G and so on. Continuing in this way, we see that the final ciphertext is ZGYZHS.
Decryption. Due to the symmetric nature of this cipher, the decryption process is exactly the same as the encryption process. Thus, for the recipient to decrypt the ciphertext, the same ciphertext alphabet must be generated as was used to encrypt the message in the first place. In this case, the ciphertext alphabet relies only on the alphabet used. Decryption example. As you can see, we use the Roman alphabet of 26 letters. Plain text alphabet from A to Z, reverse from the ciphertext alphabet from Z to A. So if we take the ciphertext X, R, K, S, V, I, we can see that the X plain text to C, then R plain text to I, and so on. Continuing in this way, we can see that the final plain text is cipher. Let's proceed to exercise 1. As you can see, the given text is the plain text, flee at once. So we're gonna find the ciphertext. So the F under ciphertext is U, then L under is O, and E under is V, then E ciphertext is V, and then A ciphertext is Z, and then T ciphertext is Z, then O ciphertext is L, N ciphertext is M, C ciphertext is X, and E ciphertext is P. So the final output, the final answer is U O V V Z G L M X V. Then let's proceed to exercise 2. The given text is the ciphertext, which is ZGG ZXP MLD. Ciphertext Z above is A, and G is T, G is T, Z is A, X is C, and then P is K, and M is N, L above is O, D plain text is W. So the answer of plain text is attack now.